Hold it. What are we talking about? Oh boy. We're trying to find the exponential function of the form CAX, where you have that c, that constant, and then a to the x, where that's just some base. Oh boy. We're waiting for some base. It's raining in California Southern. It doesn't happen very often. It's kind of a big deal. Anyways, what we're trying to do is we're trying to find this, and they give us some points, so we can go and use that first one. So we're trying to get our base, and what's that? That's our x and that's our y. So what do we have? We have that y 3. That's f of 0, y, because x is 0 and y is 3. That's f of x is the function formerly known as y. But what else? Oh, that says x is 3. So I see that's c times a x to the 0. Oh, but anything to the 0 is 1. So I have that c is equal to 3. All right. So now what's that got us? That got us that f of x is now 3a to the x. What's next? I can use that information. I'm going to take it to the top. This right here. Woo. What's that say? That says f of 2, because that's the x. F of 2 is, what's my y? That's going to be 12. So I can see that that's 3 times a to the x was 2 deuces. So what did I do? Where I saw an x, I put a 2. Where I saw a y, because f of x is the function formerly known as y, I put a 12 now. Is that really all that? Okay. So then now what? I have 12 is equal to 3a squared. And look at the nice numbered world you live in. Yeah, sure. So that says 4 is equal to a squared, which means that a is plus and minus a deuce. But can we deduce which one of these that is? Well, it's probably positive because this is an exponential and they usually list the bases as positive, so I'm going to choose it too. And that's f of x is 3, and then the base is a deuce, and the exponent is just x. Just like that. I like that. Oh, one more. I know. Make it rain. Make it rain. I actually have a camera set up just in case we get some thunder. Trying to bring thunder. Don't steal my thunder. I'm dealing with the same thing. I'm still using that same form. So I'm looking at f of 1. Oh boy. That's going to be 1. That's what. That says, okay, but what does that say? Everywhere I see an x, I'm going to put a 1. So then c is c times a to the first power, and I have that 1 is equal to ca. It hardly ever rains in California. So I guess we could solve for c in this particular scenario. Looks like c is going to be 1 over a. Really? Is this the way to do this? I don't even know. c is, 1 over a. Okay, so then what does that say? That says our new function, f of x, is our old c. Our old c, our new c, is 1 over a. And then this is, this is a to the x. Why? Because it's just like that. I like that. Oh, anyways, so this is a to the minus 1, a to the x. That's my f of x. That doesn't affect, but if I have the same base and I'm multiplying, what do I do to their exponents? Add them. Now I have my f of x is equal to an ax minus 1, because I just added those exponents. I'm going to take it to the top, because that's my new f of x. Oh man, I hope this all works out. So what, I'm trying to find my a. Let me use that business. Now, I have my y. My f of x is formerly known as y. 8, great, wait. All things point to 8. That's going to be equal to my new c of x. That's all this. So now I have an a and an x minus 1. Sure. No. Deuces. Why? Because now you had your f of x was equal to a to the x minus 1. So where you saw f of x, that's y, you put 8. Great, wait, where you had an x, you put a deuce. So you deduce that 8 is equal to a to the 2 minus 1 is 1. So what does that even say? That says that a is 1. And what does that even say? That says that c is 1 over a. So a to the first power is 8. So c is 1 over 8. You're an 8. Yeah, you hear all the rain, so I can go and I can put that in there. That's that f of x is my c, which is 1 over 8, and that's a to the x, but what was a? That was 8, great, wait. So that's 8 to the x, but what's next? I can put it in that form by transforming that f of x is 8 to the minus 1, 8. Great. X, sorry, I just felt a cat. Hi, Penelope. Yeah, and then that's 8x minus 1. Fun. Because you got the same base, and you're multiplying. You add the exponents. What's that? That was a long time to wait. Come on, get out of here. Go get a hall pass.